Hi, I am Mini. Today I am going to explain the topic feedback amplifiers. Okay, what is feedback amplifier? First we see about the introduction. What is feedback amplifier? You all know what is meant by amplifier, right? What is amplifier? It strengthens the signal. Okay, so in amplifiers it must have the source. If you give the source, if the source is weak or strong, we will use this amplifiers. Okay, if it is strong, there is no need of amplifiers. If the signal is very weak, okay, so if we use amplifiers, it will boost the signal. Okay, so then only we will get the distortionless output. Okay, now actually this feedback plays an important role in almost all electronic circuits, right? It's used in the amplifiers mainly. This feedback is used as amplifiers. Why we used this feedback as the amplifier? In order to improve its performance and make the level more ideal. Okay. So what is the definition of feedback amplifier? A part of the output signal is fed to the input. Then we can refer to as feedback. Okay, this feedback parameter may be voltage or current. Depending on the polarity of the signal, the feedback may be classified as two types. What are the types? Positive feedback and negative feedback. Okay, now so simply we can say that positive feedback, what is that? The output is added to the input, but negative feedback, the output is subtracted from the input. Okay, so if you use positive feedback, its gain increases. Okay, and some of the disadvantages is there. If you used positive feedback, instability and oscillations. Most of the positive feedback are used as in oscillators only. Okay, in oscillators there is no need of any input source. Okay, so without input source it will generate the output, but in negative feedback we need the source. Okay, so what is the main use of this negative feedback? It reduces the gain, but it improves stability, bandwidth, and noise also reduce. Okay, so most of them, this negative feedback are used as practical purpose, that is practical amplifiers. Okay, basically this feedback amplifiers consist of three main sections: amplifier part, feedback part, and summing part. Okay, then next, see this slide. This is the basic structure of feedback amplifiers. It mainly consists of three parts. I already told that. Here see, the first part is amplifier. We will represent the amplifier gain as A. So many amplifiers are there: voltage amplifier, current amplifier, trans resistance amplifier, trans conductance amplifier. Okay, so based upon the types we will use here, the gain indicates that's the ratio of output to input. Okay, we will represent that terminal as A. Okay, now the second part is feedback network. So as we studied already what is feedback, so we will represent that feedback factor as beta. Okay, so whenever we use feedback, we simply represent the term as beta. Okay, then next one, summing point. Okay, summing point. What is the meaning of summing point? It combines the input and feedback. It will summed in the summing point. Okay, so what is the main formula for we will say the gain is two types: gain with feedback and gain without feedback. Okay, if it is gain without feedback, we will say that as a open loop. Okay, open loop means simply one block is there, the input is directly given, we will get the output directly. We are unable to change any sorry, if we are unable to change the variable if it is open loop. Okay, closed loop, we will indicate that closed loop is feedback amplifier, feedback signal. Okay, so in feedback signal we will change the output, whatever output we need, that much time we will change. Okay, using the feedback factor. Okay, now this formula also varied. If you use the gain with the feedback, we will represent the term as AF, and the gain without feedback we simply represent A. A is equal to output by input, but gain with feedback, the gain formula is A divided by 1 plus A beta or 1 minus A beta, which is based upon the types of feedback. Okay, now so many feedback amplifiers are there: voltage series, voltage shunt, current series, current shunt. Okay, now so through this block diagram, what do you understand? We are given the input signal. Okay, it will directly given to the amplifier, which is taken the output, but the output is not desired. That's why you take some part of the sampled signal which is given to the feedback network. Again it will combined with the source and the feedback output, whether it may be summed or subtracted. Okay, so based upon the type, if it is positive feedback we will sum, if it is negative feedback it will be subtracted. Okay, so again and again the output will be varied. Okay, so whatever output we need, that much time it will be varied. The next one, types of feedback. From introduction part itself we studied what are the types of feedback, right? What are the types of feedback? Positive feedback and negative feedback. Okay, what is positive feedback? You simply remember that the positive feedback, the output is added to the input. Okay, so using this positive feedback, the gain will be increased. Okay, that is what positive feedback. And we will represent the term as in phase. In phase means both will be added, that we represent that as in phase. Okay, so this is the basic diagrammatic representation. The source signal, summation signal, and the output is given. So take the part of output from the output signal, which is fed back to the summation part. Or positive feedback, it will be added, both will be added. We will represent that as that plus symbol. Okay, then next one, negative feedback. Negative feedback also, what is that? The output is subtracted from the input. Okay, simply you remember like that. So there both are in phase, this is out of phase. Okay, so this is the diagrammatic representation. And using this negative feedback, the gain is reduces. Okay, but it improves. This is one of the disadvantage only, but so many advantages are there. The stability improves, bandwidth increased, and noise reduction also decreased. That is, noise reduction increased, as well as distortion. If you use feedback, distortion is reduced. Okay, now the next one is classification of basic amplifiers. We already told that in the basic structure, various types of amplifiers are there. No, voltage amplifier, current amplifier, transconductance, and transresistors. What is that voltage amplifier? Voltage amplifier, you simply represent the term as AV. A is the gain, V is the voltage. We will tell that as voltage amplifier. It's the ratio of output voltage to the input voltage. The output as well as input both will be a voltage. Okay, so that we say about voltage amplifier. Okay, so what is current amplifier? How will you represent the current? I, right? Gain is A. So A suffix I is equal to, okay, ratio of output current to input current, that is I0 divided by II. Here also the input as well as output both will be a current. Okay, that's why we will say that as a current amplifier. Okay, now conductance amplifier, it's the reciprocal of trans resistance amplifier, right? Trans resistance, what is the general formula for resistor? R equal to V by I, right? So here the conductance amplifier is what? Reciprocal. R equal to V by I. Therefore, I by V is the formula for transconductance, or the ratio of output current to input voltage. Okay. So the I by V, how will you represent that? Transconductance. This we studied in the schooling itself, right? Transconductance. Okay, GM is equal to I naught divided by VI. That is what transconductance amplifier. If the output is current and the input is voltage, we will say that as a transconductance amplifier. What is trans resistance amplifier? You generally remember that R equal to V by I. No, that R equal to V by I, we will represent that as trans resistance amplifier. That is Rm equal to the output voltage to the input current. Okay, that is what trans resistance amplifier. Okay, next, see, this is the basic structure of feedback amplifier. So what are the blocks present inside that? First, the basic amplifier with the gain A. The input is mixer, the output is sampling network. So totally 1, 2, 3, 4, 5 blocks are there. Signal source, mixer network, basic amplifier with gain, sampling network, feedback network, right? So beyond that, output side the load is present. This is the basic block diagram of feedback amplifier. Okay, so first one, signal source. Okay, what is signal source? The signal source can be, it may be a voltage source. Okay, we will connect the voltage with resistance. Okay, so this is the basic concept. Whenever we use voltage source, we will connect the resistor as series. Okay, or if it is current source, we will connect the resistor as parallel. Okay, next one, feedback network. In feedback network, it's the linear two-port network that contains resistors, inductors, capacitors. What is the main function of that? It fed back some portion of output to the input. Okay, that means it returned to the input. Okay, in sampling network, it's this network is placed in the output. Okay, it may be two types, current sampling or voltage sampling. Okay, or it may be either shunt or series with the output. The next one is mixing network. What is mixing network? It is otherwise called as comparator. Okay, this mixer part is placed, or mixing network is placed only in the input side. It is connected with our input as well as amplifier, which will be mixed using the series mixer or shunt mixer. Okay, it may be positive or negative type. Based upon the type, it will mixed there. Okay, then so now we will discuss about each and every one briefly. So first network is sampling network. What is sampling network? Actually, this sampling network consists of two types, voltage sampling and current sampling. Okay, so generally this voltage sampling network is used in sampling the system samples. Okay, output from basic amplifier voltage, which is connected to the feedback network. It may be shunt or series with the output, right? Based on the sampling signal, it is classified into two types. What is the other name of sampling network? Node sampling. See the diagram here. This is the voltage sampling, right? We are focusing in the output side, right? Because sampling network is placed in the output of amplifier. Okay, so we will connect, it may be voltage sampler or current sampler. If it is voltage sampler, we will connect the feedback network as shunt connection. See this current sampler, it will connect through the series connection. Okay, based upon the connection, the sampling network will be differentiate. Okay, then this in this voltage sampling, it is otherwise called as node sampling or shunt sampling or parallel sampling. Since the part of the output signal taken is parallel or across the load, okay, for satisfactory operation, it is desirable that input impedance of the feedback network much greater than the load impedance. Okay, in order to avoid the loading the output of the amplifier. Okay, we can say this is the sampling network also. This sampling is otherwise called as nodal sampling. Okay, then the next one is current sampling. What is current sampling? Current sampling or otherwise called as loop sampler. Okay, and again we can say it is a series sampling. Here the sampling system samples the output current by connecting the feedback network in series with the output. Okay, in order to get the desirable operation, the input impedance of the feedback network much greater than load impedance in order to avoid the reduction in current gain of the basic amplifier. Okay, so see the diagram. I already showed this. This is the current sampler. So both voltage sampler, current sampler, which is present in the sampling network in the output session only. Okay. Then next one, mixing network. So mixing network is otherwise called as comparator. Okay. So what is the purpose of mixer? It's used to mix the part of the output signal with the input. The resulting signal is given to the amplifier. Okay. Actually two types of mixing is there. Series mixing and shunt mixing. Okay. See, this is the diagrammatic representation of series mixing. From the name itself, we understand we will connect the feedback network by series mixer. Okay, so series means you already know that if the input is voltage source connected with the series, we can say this as a voltage. Input is voltage. Okay, if the input is voltage, so this is what the input is voltage here. Okay, so we can say this as a series mixer or voltage input. Okay, so this is the another one, which is shunt mixing. Shunt indicates that parallel when the resistor will be parallel if the current source is connected across the resistor, right? So we can say this as current source, or the input is current, or otherwise the mixing is shunt mixing. Okay, so in this method the feedback signal from feedback network is mixed with input signal in series or loop formation. Okay, this connection tends to increase the input impedance of the amplifier. It's otherwise called as parallel mix. So next one, shunt mixing. So shunt mixing is otherwise called as parallel mixing or nodal mixing. Here the sampled signal from the feedback amplifier is mixed with nodal form or shunted with the input signal. This connection tends to decrease the input impedances. Okay, then okay, for basic feedback topologies, there are four possible configuration of feedback amplifiers based on the sampling and the mixing. Okay, so what are the types? Voltage series feedback, current series, voltage shunt feedback, current series feedback, current shunt feedback. Okay, these are the four basic feedback topologies. Above four configurations, the first part says the voltage or current. Okay, that's the method of sampling network, and the second part says series or shunt. This is meant for mixing. Okay, example, voltage indicates that method of sampling. It may be connected, it is shunt or nodal mixing. If it is shunt feedback, this method is mixing. Here it is shunt mixing. Okay, so first one, voltage series feedback. Voltage series feedback. This is the diagrammatic representation of voltage series feedback, right? It is also called series shunt amplifier. Okay, series shunt amplifier. Which type of amplifier used here? Voltage amplifier. What is the definition of voltage amplifier? It's the ratio of output voltage to input voltage. Here the output as well as the input both will be a voltage. Okay, that's why we will say this amplifier as a voltage amplifier. What is the input here? The input is voltage, no, because two types of mixing you know, and as well as two types of sampling we know, right? Sampling is voltage sampling or current sampling, mixing is series mixing or shunt mixing. See this topic, voltage series feedback. Okay, the first part indicates the output sampling network. Okay, so we will connect the output as or take the samples in the voltage part. Or voltage part means you know, if the source series with resistor, that is what voltage. Okay, but in output side we does not represent like that. Okay, so if it is parallel, we say that as a voltage. Okay, so this is the parallel connection or voltage sampling. Okay, see the input side, we know that there is one mixing network is present, right? In mixing network, two types of mixing is there, series mixing or shunt mixing. From the topic or voltage series indicates that the series part is the input part or mixing part. Okay, in this mixing part you take the connection using series method. Okay, so which if the resistor is connected in series, what is the amplifier or what is the source present there? Series means voltage, no? That's why input as well as output both will be a voltage. You simply represent that as amplifier as a voltage amplifier. We can say the other name as series shunt amplifier. Okay, here the sampling parameter is voltage and the mixing fashion is series. So the formula is A is equal to V naught divided by Vi. Okay, the output is directly proportional to the input voltage. We can say this as a voltage amplifier. Okay, this is what a voltage series amplifier. Then the next one is what? Next one, current series. See the diagram. From the diagram itself we understand. Okay, so which type of amplifier used here? See, the output is current and the input is voltage. Okay, that is why this is what transconductance amplifier. The name of the amplifier is transconductance amplifier. What is the other name of the current series feedback amplifier? Series feedback amplifier. How you identify this as series feedback amplifier? See the input side, we will connect the feedback by series mixing, right? How to take the same samples from sampling network? By series method only. That's why we can say this as a series feedback amplifier. Okay, so why you are tell this as a current series feedback amplifier? Current indicates that sampling network. Okay, current is the first part which indicates the output of sampling network. Okay, so if it is current, actually the current means we will connect the resistor as parallel, but here we will connect this as a series, because you just remember in output side we will take this as a reciprocal of actual method. Okay, so what about the input side? So input side as it is, that is current series, so you will connect the second part as series, no? So directly connect through the series method. Then but how will you find the amplifier? We need the output as well as input, no? We identified output is current. How to identify the input? Here we mentioned only series, no? How to identify this as a voltage or current maybe? Okay, so series, we will connect the resistor series, means that is what? Voltage. Okay, so here the output is current, the input is voltage. That is trans resistance amplifier. It's the ratio of output current to input voltage. Here in see the feedback factor network. Okay, what is the output of we know beta is the feedback factor. Okay, so what is the output of feedback factor? Vf, because input is voltage, no? So Vf. What is the output taken from the amplifier? Current. Okay, so here the feedback input is current, feedback output is voltage. Okay, this is also ratio of output by input. The output is Vf and the input is I out. Okay, so this is what current series feedback amplifier with transconductance amplifier. Okay, so current series feedback amplifier is otherwise called as series feedback amplifier. Here the sampling parameter is current and the mixing fashion is series. Okay, here the output current is directly proportional to the input voltage, so A is equal to I naught divided by Vi, and this is also called transconductance amplifier. Okay, understand? Then the next one is what? Voltage shunt feedback. Okay, next we see about that. Voltage shunt feedback. Okay, what is that voltage shunt feedback? It is otherwise called as shunt feedback. See the block diagram. Okay, which type of amplifier used here? Trans resistance amplifier. How to identify this as a trans resistance amplifier? Here the output is voltage and the input is current. We know that the general formula for resistor is R equal to V by I. Okay, that's why this amplifier is trans resistance amplifier. Okay, then how you identify this as the output is voltage and input is current? Because by using the sampling network and mixing network we will easily identify. See the sampling network, where you see the sampling network? In the output side, the output of amplifier. See how it connected? It take the output from series connection, right? Not shunt connection, parallel connection. Okay, so if the connection is parallel, we will say that that sampling is voltage sampling. Okay, then see the input side. Okay, so voltage shunt feedback, the second part is shunt. The second part indicates the input of amplifier. Okay, see this as a shunt means parallel. While connecting parallel, we can use the source as current source. Okay, so this is what we will say this as output as voltage and input is current. Okay, see the feedback factor. The third block is feedback factor, right? What is the representation of feedback factor? Beta. What is beta? It's the ratio of output to input. Here the feedback input is voltage and the feedback output is current. Okay, so simply we will tell that feedback factor of trans voltage shunt feedback is the ratio of output current to input voltage. Okay, so the voltage is taken from output of amplifier, that is V out, and the output is taken current, that is feedback current IF. Okay, so this voltage shunt feedback is otherwise called as shunt feedback. Here the sampling parameter is voltage and the mixing fashion is shunt. Here the output voltage is directly proportional to the input current. It is also called as trans resistance amplifier. The gain of the trans resistance amplifier A is equal to V naught divided by II. Okay, the next one, last one is what? Current shunt feedback. Current shunt feedback. Okay, this is the block diagram for current shunt feedback. Which type of amplifier used here? Current amplifier. Why it is current amplifier? Because the output as well as input both will be a current. The current gain A is equal to is the ratio of output current to input current. Here also the sampling part, see the sampling part, take the samples from series or take the samples through series to the feedback factor. Okay, that's why then the name is current sampling. Okay, next we will mix the feedback factor with the input using shunt fashion. So if it is shunt, which type of source is used here? Shunt is parallel, right? So current source, so current parallel with resistor means current amplifier. Okay, So here the amplifier used the output as well as input as current. That is what current shunt feedback. So it is otherwise called as shunt series feedback amplifier. Here the sampling is current parameter and the mixing fashion is shunt. In this case, the output is directly proportional to the input current. Hence, both are in current. Okay, so it is called current amplifier. The formula is A is equal to I naught divided by I. Okay, so now we will reach the end of the session. Okay, so finally, so what is the conclusion of feedback amplifier? It improves the overall performance of an amplifier by feeding a part of output back to the input, right? Among the two types, negative feedback, there are two types of feedback amplifier. We already explained that positive feedback and negative feedback. Among the two types, negative feedback is widely used because it provides stable gain, reduces distortion, increases bandwidth and improves reliability. Okay, although it slightly reduces the gain, the advantages make it highly suitable for practical electronic circuits. Okay, so on the other hand, the positive feedback is mainly used in special applications like oscillators. Okay, so feedback amplifiers help in achieving better control, accuracy and stability in signal amplification systems. Okay, I think you all understand. Thank you.